Okay. So we are talking, there's actually 5 formulas, even though there's only 4 listed in the essential question there. We're going to focus in, all I got to 0 period was double angle. I'm hoping tomorrow to do the half angles and the power reducing and spend a little less time on homework questions. As we did the product to sum to product. So we're probably looking at some kind of an assessment Friday-ish is what I'm thinking, okay, to get this over and done with, and then we'll move on to our first chapter of calculus, okay? All right, so too fast. So these are the double angle formulas. I believe they're typed there for you, aren't they? Okay. And they're also on your pink sheet, so you can reference your pink sheet, you can reference your notes, but the pink sheet has all of them together, okay? So they aren't always explicit about saying double angle, okay? You know it's a double angle because inside the angle there, it says 2 times something, okay? Another way, or 2 times an angle, 2 times an x, 2 times a theta, 2 times a beta, something, okay? It could also be something like this, 4 theta, which could be broken into 2 times 2 theta. So it's always even in there, and that's an indicator of a double angle, okay? I'm not going to go through each one of the specific formulas. We'll do them as we're going through the notes. The only thing to be aware of is that on the cosine one, there's 3 possibilities. They are all equivalent of one another, okay? It doesn't matter which one you use. Sometimes one works better than the other, okay? I was noticing as I was doing the homework, the first example's good. It isn't exactly this way in the homework, but it should help you with the last part of the homework. This is kind of similar to the last part of the homework. So we've got a nice triangle there. It should say 8, 15, 17. They told me it was typed funny. There were floating numbers. Okay, sorry about that. And then it's missing the reference angle. The X is going to go in the bottom right-hand part of the triangle. Okay, you should not need my help to do A and B. You've been doing those since geometry. So do cosine and sine of that triangle, please. All right, we got it. So what did we write down for the sine of that triangle? Good. 8 over 17. Perfect. What about for the cosine? 15 over 17. Now, 2x does not mean just multiply it by 2. It doesn't mean squared. It means you have to apply the double angle formula. Notice, did they say to use double angle? No, you had to recognize that this is twice the angle. So I have to deal with the double angle formula. So I'm going to move my work for part C here. Okay. It doesn't matter which one of the cosine formulas I work with. I'm going to choose to do the one that it says, isn't it cosine squared minus sine squared? Is that right? Yeah, cosine. So I'm going to go, let me just flip back one. I'm going to choose to use this formula right here. Cosine squared minus sine squared for my double angle this time. It doesn't matter. I could pick any of them. Okay. So I'm going to do my cosine, which is the 15 over 17 squared, minus the sine, which is 8 over 17 squared. All we're doing is evaluating, so we're plugging our triangle values in, and we're coming up with a number. All right. If you don't remember your square numbers, there are some posters up in the room that'll help you with them. One's over there, one's by the door. Okay. So tell me, what is 15 squared? 225. And what's 17 squared? And I get that twice, right? What's 8 squared? 64. Good. All right. So 225 minus 64 is 100 something. Yes. There we go. 161. Now, look at your double angle formulas again. Look at them on the pink sheet or up in your notes. Do we have a double angle formula for secant, cosecant, or cotangent? No. So how am I going to get those? Yeah, we're going to do the reciprocals just like we did last year. So this one here, I'm going to go ahead and flip the reciprocal for cosine, which is going to be 289 over 161. Okay. All right, I'm going to do D now. So D says it wants the sine of 2x. So look again at your formula sheet. What's the formula say? 2 sine times cosine. All right, so what is the sine of the triangle that we wrote down? Good, and what's the cosine of the triangle that we wrote down? 15 over 17. Even on my thing, it's delayed. There it goes. All right, I know the denominator is 289. So 2 times 8 times 15. 30 times 8 would work too. What do we get? 240. All right, so what do I get for free off of sine? Cosecant. So I'm going to go down here and 289 over 240. Mm-hmm.
You don't multiply 2 to the denominator, right?
No, it's technically in the numerator. Okay. Sorry. All right, then I'm going to do my work for E. So tangent of 2x equals, we don't do a ton of tangent in the examples today, but you got to do a few in the homework. 2 times the tangent, sorry, I got an extra little mark there. 2 times the tangent over 1 minus the tangent what? Squared. All right, so you have some options. You can do sine over cosine to get the tangent, right? But they gave you a right triangle. Couldn't we just read it out of the right triangle? Yeah, okay, so what is the tangent of the right triangle there? 8 over 17. Nope. 8 over 15. That's a little bit better. Okay, I'm going to see if I can squish my work in here. So I've got, let's see, what's 2 times 8? 16 over 15. I'm going to wait to write my 1 because I want to work smart and not hard. What's 8/15 squared? 64 over 225. So instead of writing 1, it's better for me to write 225 over 225. I'm going to have to do my work horizontally. So I've got 16 over 15. What's 225 minus 64? Do you see how that number popped up again? You're probably going to be limited to just a couple of numbers. It's not going to be all over the place. There should be like 3 or 4 numbers that you're working with total. All right, then in order to get that simplified, I would probably do my good old flip and multiply, right? So 225 over 161, or multiplied by the reciprocal is the proper way to say it. How many times does 15 go into 225? 15, maybe. All right, and then let's see, what's 16 times 15? 240. And then what do I get for free from tangent? Cotangent. So I'm going to flip that 161 over 240. Let's see if I do this without the keyboard, if it will help the situation. All right, we good with example 1?
Yeah.
The difference on the homework is it's only going to give you, it's not going to give you the triangle. It's going to give you like what the sine is, and it's going to tell you what quadrant it's in, and you got to figure out the other measures. Okay, so it shouldn't hopefully be too big of a deal. If we need to, we'll answer questions on it tomorrow if we have to. Okay. All right, let's look at number 2. We're doing on time 38. Good. All right, we got to find the exact solutions of the equation algebraically. They gave us the interval. That means just 1 revolution around the unit circle. Okay. So what the idea here is before I can do any kind of factoring to it to be able to solve and use the zero product property, I need to get rid of the double angle. So do you see the double angle guy hiding out here? So I'm going to substitute in for that. So I'm going to keep my 2 cosine. What is the, so what can I substitute in for sine 2x? 2 sine x cosine x equals 0. All right. Then do you notice in here that there is a greatest common factor in there? 2 cosine, isn't it? So couldn't I pull all of that out? So I'm going to take out the 2 cosine x. What's left behind in the first spot? No, what's left behind here? A 1. Sorry, it's not writing. Come on. I'm asking it to do way too much right now. There's the 1 I've written a million times. Plus, what's left in the others in the second spot? Just sine x. Okay. Now we're ready to do zero product property and tear that apart and set each term equal to 0. So we're going to do 2 cosine x equals 0 and 1 plus sine x equals 0. What am I going to have to do to the left side here? Divide by 2, so I get 0. And then what do I do to the second one? Subtract 1, so negative 1. All right, at this point, now it goes back to what we started kind of midweek last week, right? Where we have to evaluate. So I went back and redid that. So x equals, so places, let's see, cosine is the x value, right? So what places is the x value equal to 0? What radian measures? Everybody okay with that? All right. And then sine is the y value. So you're looking for your y value to be negative 1. So where does that happen at? Just 3 pi over 2. We good? Okay. All right, a little bit different on example 3. So on example 3, again, I want to replace, my goal is to, first of all, if I see that double angle in there, I really want to get it out because it's harder to solve when I have it in there, okay? So I'm going to replace this double angle. What do I get to put in for sine 2x? Good. 2 sine x cosine x equals cosine x. I'm doing this really slow. I could have probably done more than one thing at a time. In my next line, I'm going to try to combine like terms, and I need to get it equal to 0 in order to find solutions. Not quite yet. First, what's sine times sine? Sine squared. Remember, the squared goes on the sine, not on the x. And at the same time, how do I move this cosine to the other side? Right now it's positive, right? To get it to the other side, I need to make it subtraction, right? Good. Now go look for the the greatest common factor. What is it? It's cosine x. Let's see if I can get up. It flipped on me. Back. There it is. Okay, so cosine x. I'm going to take that out. So cosine x is coming out. What's left behind?
2 sine squared x minus 1.
Good. All right, well, here's what I want you to do. I want you to do it from there. So do the zero product property. We're not probably going to do example 4, so if you need more space, you can use example 4 space. Do the zero product property, get it evaluated for me. All right, look at how far I got. I went and just did the to zero product property, and I evaluated, at least got it down to cosine x and sine x. Do you agree with my numbers?
Yes.
Okay, so for cosine x, we're looking for 0 in the x spot on the unit circle. What radians did that happen at?
3 pi over 2, pi over 2.
Sorry, it's skipping. 3 pi, or pi over 2 and 3 pi over 2. Good. All right, this is plus or minus square root of 2 over 2 in the y spot. Where did that happen?
Pi over 4, 3 pi over 4, 7 pi over 4, and 5 pi over 4.
5 pi over 4, and so everything over 4, right? Oops, sorry. What is going on? I didn't even touch it. I took the keyboard off thinking that was the problem, but it's not. All right, we good? We can handle that part? Okay, we're going to skip 4. Let's do 5. 5 is the one that's in the homework the way it looks, and this was very similar to the first one. Since we've got the extra time, we'll do it. 0 period, I was running out of time. Okay, so what it wants me to do here is they want me to find all 3 things. The sine of 2, this cosine of the double angle, and the tangent of the double angle. They gave me one thing, right? They gave me a 5 over 13. What quadrant is it located in? What does that mean? It's the 4th quadrant, right? Between 3 pi over 2 and 2 pi, right? So that means basically what's going on, and I know I didn't do a lot of this with you, is there's a triangle down here in the 3rd quadrant, okay? And the cosine of that triangle, so the cosine is the adjacent, right? So the adjacent leg is 5, and the hypotenuse is 13. What does that make this other leg? It's a Pythagorean triple. 5 what? 13. It's 12. But because we're going down, what should I put on the 12? A negative. So I have to be careful and just make sure that my answers make sense for my quadrant, quadrant 4. In fact, it's probably a good idea to just calculate the sine, the cosine, and the tangent, because I need all of those things, and then I've got them and I can just read them off. So of that triangle, what's the sine of u? I think I heard negative 12 over 13, right? I'm sorry that wrote the way it did. It's a negative 12. I don't know if I can erase that and start over. Let's see. Erase that little mark. Yep. Okay, we'll fix it. That is too icky to leave. All right. Negative 12 over 13. And then what's the cosine of that triangle? Oh, they told us that, right? We don't need to calculate it again. We've got it, right? But I could find the tangent. What's the tangent of that triangle? Negative 12 over 5. So that should give me enough to fill in those 3 formulas, right? Okay, so let's start with sine of 2u. All right, what's the formula say? Two sine times cosine. All right, what are we going to put in for the sine? Good. What are we going to put in for the cosine? 5 over 13. All right, and then what do we get when we multiply across the top and across the bottom? I like the 169. I also like the negative 120. I think we missed a 5. Or the 2 in front, probably. 2 in front. Okay. All right, let's look at cosine. So I'm going to use a different one this time. So last time we used the sine squared minus cosine squared, or cosine squared minus sine squared, right? This time let's use 2 cosine squared u minus 1. And it doesn't matter. Okay. Go back. There it is. It does not matter. You get to pick whichever one you want. But if I only had to find the cosine of 2u, and I didn't have to find the sine first, and since I already have that number, that would be the quickest one to get there, okay? All right, so 2, what's my cosine? 5 over 13 squared minus 1. All right, what's 5 over 13 squared? Good. Minus 1. And then 2 times 25 is? 50 over 169. And then I got to subtract 1, but I'm going to write a fancy 1. 169 over 169. So what's 50 minus 169? Over 169. Oops, sorry. Come back. Go back. There it is. All right, and then we got to do the tangent. So tangent of 2u equals, I didn't even touch anything that time. Okay. So what's the tangent say? What's the tangent formula say? 1 minus tangent squared. So I need my tangent. What's my tangent? Good, and then we're going to put that in there both times. All right, so it looks like my numerator, negative 24 over 5. Is that right? Okay, I'm not going to write my 1 yet. What's negative 12 over 5 squared? Good, and so instead of writing 1, what am I going to write? Good. All right, I'm going to take an extra shortcut on this one. All right, well, maybe. So I have this negative 24 over 5. At the same time, I don't know why I wrote an equal sign. At the same time I'm doing this subtraction, I'm also going to flip it. Can we handle that? So what's the 25s are just going to stay 25s. And then what's 25 minus 144? Negative 119. Thank you. Are we okay? Everybody see what I did? So I did this subtraction, but I flipped it at the same time so I could do my flip and multiply. Okay, or my multiply by the reciprocal. We okay?
Yeah.
I was trying to save steps and space. And you're in calculus now, you can handle that, right? All right, 5 into 25, how many times? 5, good. That's a 5, not an 8. So let's see. I'm seeing, negative and negative, what's going to happen there? Positive. Okay, so 24 times 5, I know it's 119 on the bottom. 120 over 119? 120 over 119. Ah! I don't know why I did that. Go back. Go back. There it goes. Okay. All right, we got to work the formula the other direction. So we're going to we're going to do 7 and 8. Okay, and that's where we're going to call it good because that's as far as I got in 0 period. I'm not going to have you guys all off of them. Okay? Yeah. You have to take the class. All right, you ready? Okay, so remember when we did the sine, cosine, cosine, sine, and we were able to write the formula both directions? That's what this is about. They want you to use a double angle formula to rewrite the expression. So I need to get this piece here to look like one of the formulas on the list. Well, it looks really close, but not quite. So what I'm going to do is I'm going to rewrite the 4 as 2 times 2 sine x cosine x plus 1. Doesn't this piece here look like one of our double angle formulas? So what double angle can I substitute in there? Sine 2x in this case plus 1. That's all there is to it. Okay, it's substituting the formula in for and recognizing that you've got an equivalent statement there. Okay. All right. One more. Last one we're going to do. What does instinct tell you to start doing? FOIL. Okay, but I want you to look very, very carefully. Do I need to do all of FOIL? Why not? One's a plus and one's a minus. What do we call that? Good job. They're conjugates of each other. Okay, so that means I only need to do first and last. That's our shortcut. So if you're coming out of pre-calculus, I don't know if you learned that shortcut or not last year, but if we were going to multiply all of FOIL out, our O and our I would end up canceling. So that's why we do that when you have these signs opposite here. So what's cosine times cosine? Cosine squared x. And sine times negative sine. Good. All right, I want you to look at your double angle formulas. That whole thing is equivalent to cosine in this case 2x. Okay? Sound good? All right. That gives you just enough time to go look at the homework and get it written down. Okay? I will take care of stamping tomorrow. Okay, so we'll do all the stamping for week 2 tomorrow. I know we did a little bit on Friday or Thursday or something. Okay?